You walk out to the backyard after a heavy storm, and the chicken run looks like a stepped-on soda can. The metal frame is bent, the mesh is sagging, and the whole structure is hovering just a few feet off the ground. The storm might have been the final trigger, but the actual cause is usually a creeping weight penalty. Over months, organic matter, like thick, dead vines, accumulates on the roof, slowly crushing the frame under a continuous heavy load. Right now, that ruined structure is essentially a loaded spring. The roof is caved in, the thin metal tubing is fatigued, and the sidewalls are bowing inward under the pressure. It's tempting to grab a few friends and try to heave the roof back into place, but forcing a compromised frame back into shape is often what triggers a total collapse. Take a look at this common improvised repair attempt. It's a janky tower built out of shipping pallets serving as a center support, combined with crossed wooden boards trying to pry the roof upward. Those long lever boards are holding significant mechanical tension. If they slip off the metal frame, and raw wood against metal is notoriously slick, the entire load drops instantly on whoever is standing underneath. There is also the risk of the pallet tower racking. Because it's just stacked wood, the tower can twist and fold sideways under downward pressure, causing the entire temporary lift to fail without warning. You don't need a construction crew to fix this safely. You just need to use basic physics to take the weight off your back. The first engineering principle we need to apply is rigidity. That wobbly pallet tower is essentially a stack of rectangles, and rectangles naturally want to fold flat when pushed from the top. The solution is the diagonal X-brace. By screwing a few scrap boards diagonally across the frame, you transform those collapsible rectangles into rigid triangles. A triangle cannot twist or fold, which locks your support tower firmly into place. Next, we have to address load distribution. The current DIY setup concentrates all the lifting force onto a single metal rib. Pushing heavy weight into such a narrow point will kink and ruin the thin-walled tubing. By placing a wide flat cap, like a 2x6 board, on top of our lifting column, we move away from a dangerous pinch point. We are spreading the force across several metal ribs, protecting the frame as it rises. Achieving rigidity and distributing the load are the essential prerequisites. They allow a solo builder to lift the entire roof section without damaging the metal tubing. With the area stabilized, we can apply mechanical advantage. It's time to move past the dangerous wooden levers. The right tool for this job is a basic 6-ton bottle jack. To use it safely, you build a specific stack: a ground board to distribute weight on the soil, the bottle jack, a vertical 4x4 post, and your wide cap board at the top to cradle the roof. By pumping the jack handle, you raise the structure in small half-inch increments. This allows for elastic recovery, letting the bent hoops ease back into shape rather than being forced into a snap deformation. As the center of the roof rises, the sidewalls will naturally want to bow inward. You have to pause and wedge temporary props against the walls, pushing them outward, so the structure remains stable as it gains height. Using hydraulics and proper staging turns what looks like a two-person job into a controlled, manageable process for a solo builder. You've got the roof back to its correct height, but the job isn't done. The metal tubing is weaker than it was before the collapse, and the next heavy storm could drop it right back into the dirt. To make the repair permanent, you need to slide a wooden ridge beam directly down the center peak, underneath the metal hoops. You secure that wooden beam to the hoops using pipe straps and support the entire length with vertical posts running down to the ground. Finally, you slowly twist the release valve on your bottle jack. The weight of the chicken run transfers off your temporary lift and onto the new, permanent wooden frame. The last step is to clear the remaining dead vines off the exterior. Removing that mass is the only way to stop the next collapse before it starts. Restoring a collapsed run doesn't require a construction crew.